This was a tricky question overall, particularly towards the end with the maths. Well done for those that gave it a go. For the first question, you needed to realise that both of them were not moving, so the momentum at the start was 0. That means that why the skateboard moves backwards, well, if the skater moves forwards, that's going to give him a positive momentum afterwards, and it's got to cancel out so that the total momentum is 0 after they've finished moving, so it's got to have a negative value. My question to you would be, why does the skateboard move faster backwards than the skater moves forwards? Well, it's because the skateboard is lighter. For the second question, you had to calculate the velocity at which the skateboard moves backwards if the skateboarder jumps forwards with a velocity of 0.3 meters per second. Well, we know that the momentum of the skateboard has to equal the momentum of the skateboarder. So the mass of the skateboard is 42 kilograms and they move forwards at 0.3. And we know that it's got to equal that of the skateboard. Now the skateboard is 1.8 and we don't know how fast it's moving, so I'll put a V just there. We can rearrange the equation, so V equals 42 times 0.3, and that's then divided by 1.8, so our final answer is around 7 meters per second. Question 2 was the first part anyway, was answered reasonably well. Calculate the momentum of the ball just before the collision. Well, the ball has a mass of 1.5 and before it collides it's moving at 4 meters per second, so the answer is 6. And what's the total momentum of the balls A and B after the collision? Well, before and after the collision the momentum is the same. So if the momentum of ball A was 6 at the start, ball B, it says, isn't moving, so 0. So the total momentum after the collision must be 6 plus 0, so the answer would be 6. And then the momentum of ball A just after the collision, well, it says just here that ball A is now moving at 1 meter per second, so it's got a mass of 1.5, a speed of 1, so the answer here is 1.5. And then calculate the momentum of ball B just after the collision. Well, to start with we've got 6, it's then 1.5, so it's the difference between the two that's left over. So 6 minus 1.5 equals 4.5 that's left over for the ball B. And then finally, to calculate the velocity of ball B just after the collision, well, we know the momentum 4.5, we know its mass 1.5, so the answer there is 3, although this person here got it wrong. We got it right, but for the wrong reasons. Calculate the loss of kinetic energy in the collision. This one was tricky. You had to look at the momentum before the collision and then work out the total momentum after the collision, and then finally take one away from the other. So before the collision, it had 12 joules of energy because the equation 1/2 times mass times velocity squared. So before the collision 0.5 multiplied by 1.5, and it was moving at 4 meters per second, so 4 squared 16, and that equals 12 joules. After the collision, we've got one of the balls, so 1/2 times 1.5. So the first one was moving at 1 meter per second, so 1 squared is just 1, that's 0.75. And the second ball was moving at 3 meters per second squared, so 3 squared is 9, and that's 6.75. So the total kinetic energy afterwards was 7.5, but we want to find the difference, the loss. So the final step is to do 12 minus 7.5, so the answer is 4.5 joules.